Hi and welcome. Today we're going to be talking about derivatives of parametric equations. And I'm going to start off with this equation of y equals t squared and x is equal to the root of t. So in regular calculus, calculus 1 in fact, we ask this question: what is dy dx? But here notice, I'm given y in terms of t and x in terms of square root of t. I want to know what this is without having to solve for y in terms of x. Okay, so one thing that you should notice is that dy dx, this is equal to dy dt divided by dx dt. Okay, and let's just check this. I'm going to differentiate y with respect to t. That's going to be 2t, that's dy dt. And then I'm going to differentiate x with respect to t. And, here I'm going to do dx dt. This is going to be 1 over 2 root t. So I'll have 1 over 2 root t here. And I need to simplify this. So keep in mind the numerator, I can divide it by 1. And I'm going to get 2t over 1. I'm going to flip and invert the denominator. This is going to be 2 root t over 1. This is going to be 4 times t to the 3/2 power. And, just in case you're curious, dy dt, that was 2t. Okay, now that is dy dx. How could we verify this? Well, I happen to have a pair of equations which I can solve for y in terms of x. So notice x is equal to root of t. That implies that x squared is equal to t. So y is equal to t squared tells us, hey, t squared is going to be, and t, we have an equation for x, it's going to be x squared. So y is equal to x to the 4th. Okay, great. Y is equal to x to the 4th, and this tells us, hey, dy dx is equal to 4x cubed. Hey, is that the same equation that we had before? So before, we had an equation for dy dx, and it was that dy dx is equal to 4t cubed, or 4t to the 3/2 power. But remember that t is going to be x squared. So this is x squared, and using the rules of exponents, this is 4x cubed. So we get the same answer. Okay, so the moral of this story is that if I want to compute dy dx, it's just going to be dy dt divided by dx dt. Okay, and one question is, hey, why would I ever use this formula? Why would I ever use this formula if I can have y in terms of x? Well, that's just the point. It's not every day that a parametric curve is expressible as y in terms of x. It's not always easy to solve. Okay, so just keep that in mind. Okay, now here's a warning. And it's this. It's something very innocent looking. It's that the second derivative of y with respect to x is not equal to this. It's not equal to the second derivative of y with respect to t divided by the second derivative of x with respect to t. Let's verify. Okay. But before I verify, let me give you the correct formula. Okay, as that will be part of our verification. Okay, so our correct formula is going to be this. Is going to be that the second derivative of y with respect to x is the first derivative with respect to t of y with respect to x divided by dx dt. Okay. Well, let's verify this, okay? Well, one way I'm going to verify is I have this first derivative. I have y prime. What happens if I differentiate it again? So note dy dx squared, that's equal to d over dx of, well, we calculated this before, it's 4x cubed. So we need to differentiate the first derivative. And I think this will give me 12x squared. Okay, so this is the correct answer. And we know that from Calculus 1. Okay, well, what happens if we use this correct formula? And let me not put a line through it, so I'll rebox it. Our correct formula is right here. Well, this is telling me, hey, I need to differentiate dy dx, and dy dx is 4t to the 3 halves. 4 times t to the 3 halves. I differentiate that with respect to t. I divide by the derivative of x with respect to t. dx dt is 1 over 2 root t. 1 over 2 root t. Okay, so that's just using this formula. So that is this formula. D over dt over dy dx divided by dx dt. Okay, that is the second derivative. I need to differentiate the numerator. Is going to be 4 times 3 halves times t to the power of 1 less, which will be 1 half, divided by 1 over 2 root t. Well, let's invert and multiply. Okay, so we invert and multiply. This will be 12 over 2, and this will be t to the 1 half power. I invert and multiply the denominator, and let me write that as t to the 1 half power instead of square root. After all, those are equivalent. And I cancel that, and I'm left with 12 times t to the 1 half power, to the first power. But then remember, hey, we solved for t in terms of x right here. T is equal to x squared. So we plug that in, that's equal to 12 times x squared. Great. So we got the same answer when we used the formula in the box. So this is a warning here. This is not equal to. And let me put a big no. Okay. This is not equal to dy dt squared over dx dt squared. Well, dy dt we calculated. Dy dt was 2t, so the derivative of that will be 2. The second derivative of dx dt is the derivative of 1 over 2 root t. That will be minus 1 over 4 times t to the 3 halves. Okay, so let's just invert and multiply that. That'll be 2 over 1 times by 4 times t to the 3 halves over 1. I think this will be 8 times t to the 3 halves. And if we remember that t is equal to x squared, this will be 8 times x to the 3 halves x squared to the 3 halves power. Okay, so this will be 8x cubed. So this is a big no here. This is not equal to the derivative of 12x squared. It will lead us awry. So no, don't do it. Okay. All right. So that was my little review and lesson on calculus here. We're going to move on in another lecture and discuss further aspects of calculus and polar coordinates. Thank you for joining.